And hello, students. This is a follow-up to Chapter 4S.5, problem Chapter 4S.5, where we had systems with certain reliabilities. We had to figure out what the overall reliability of the system is. But actually, I had a question about this question, first problem here, that's a little bit, just a little bit more complex than Chapter 5. The complexity of problem 5, rather, is that it was a word problem. This one, we're kind of just straight up told what to do or what the system looks like, and then we have to figure out what to do. Okay, so the whole approach to this is that we have systems that have sequence to them, like a sequential system, A and B, like we have in the picture over here, that. And to find the reliability of that is pretty straightforward. Reliability of A times the reliability of B is equal to reliability of the system. Okay, so we're going to get into, let's put that in here right now. So let's get that out of the way. So this is going to be, I'll type this in as the reliability of A and B. Okay, equals 0.90 star 0.90. So the first answer would be 0.81. Okay. The second part of the system says each system has a component that has a backup with probability of 90.9 and a switch that is 100% reliable. So that would just look like this. All right, we're going to put a little switch in here. All right, we think of that as sequential to the backup. Okay, so this is a backup, a primary. Okay, that's going to go to B, primary. We have the second switch here. This is B backup. Okay, when we have a system that looks like this, put the equation in here, we would end up getting the reliability of A plus 1 minus the reliability of A times the reliability of A backup. A backup, like that. Okay? So always use the parentheses either for yourself to be clear or for those that follow if they're going to use a spreadsheet after you. Right? It's a good habit to be into so we don't. Things are much clearer this way when you put your own parentheses in here. Let's run that out. So that's equal to point, which we're at least at 0.9. Okay, and then we're going to add a couple parens. 1 minus 0.9 times another 0.9. Everything's 0.9 in this problem. Okay, so let's see how many digits we need to here. I'm going to push that up a little bit so we can see some more digits here. So it's exactly 99%. Okay. Okay, so that is the reliability for one of these systems, but we have two in sequence. Okay, so we need to do that twice. So this is still problem B, part B. Okay, so it's just going to be equal to that number squared. So we should get 0.9801. Okay, so now that is the reliability for the switch being at 100%. So let's go to C. Let's go to part C here. So let's see what those are. Okay, so how will this change? It's almost the same equation. All we know, though, is that this tends to be in sequence. Okay, so this gets set up when you have this parallel backup in place. The switch we didn't have to account for. Okay, but what happens there is the reliability of the backup depends on now the reliability of the switch times the reliability of the backup. Okay, so here's the reliability of the backup. We just need, in part C, we just need to multiply the reliability of the backup by point, what did they say? Switch is 99. Okay, so we're going to multiply that by 0.99. We're going to shave just a little bit of reliability off of it, the whole setup here. Okay, so what I'm going to do is I'm going to grab this. No, I need to grab this one here, and I'm going to take that equation It's a little bit of a hack, quick way to do this. All right, I'm going to put my equation in down here. Okay, we're going to end up squaring it, but what we need to do to modify this is we just need to multiply this by 0.99. Okay, so now remember that is one system with only, we don't have them in sequence yet, okay? So that's just one of them. So we're comparing these numbers, and we'll notice that we dropped by 0.0009 from the original reliability of one part of the system. Okay, so I'm just talking about like one of these. Okay, so this is where we can see that the reliability dropped, okay? And then we have two of them in sequence, so that's just going to be equal to this squared. So the reliability of the system drops down to what, 97.83 because of the switch. And this we compare to, grab another color here. Okay, this we're comparing here. Okay, so that the final system comparison, or comparing the reliability of the system with the switch in there, dropped just a little fraction there. But it's the percentage will add up over time. And if you take, I always think of, like, for some reason, I think of a warship or military aircraft or something, or any aircraft. Inside an aircraft, the reliability of all those systems, we're just touching the surface of what goes on as far as reliability for, say, aircraft goes. Okay, why? Think about this. This is just a nice application. Really, an aircraft jet you get on is made of three major parts, right? Basically, the engine, power plants, whatever that is, right? Then you have the actual frame thing that you sit in with the seats and wings and all that kind of part. And then finally, this is where complexity explodes, is in the electronics. Okay. All right. So when they build, a big 777 here, 747s are still uh, the biggest 7 series Boeing makes. But each of these are intertwined here. Each of these systems then has a complex final solution for total reliability. And of course, we're still waiting for that 737 to come out and be corrected. Okay, I'm not sure that's ever going to happen though. But anyway, that's a little bit of an application in real life, thinking about aircraft and thinking about the reliability, about how all that adds up, and how specific engineering groups are involved just to maintain that and understand what the reliability is. Right. Okay. Hopefully that helps. We'll see you soon.